here's a QR code and a link to the Shadertoy site where you can get all the materials, and I will publish the shaders that I'm going to show in the screen when their time is. So maybe we can go on and start. So shadertoy.com/user/waffles in plural. So first of all, so if you already know about shader coding, I will then talk a bit about materials and references that you can get inspired. So here are some links to the workshop examples. Then there is the shadertoy.com documentation, which gives you a bit of an overview that what kind of functionality shadertoy.com has. And the shadertoy.com will be the platform of the fast effect compo. So we are not expecting you and that you would submit any kind of executable or anything. So you need to do your entries in shadertoy.com and then submit a link to your shader. But I will show you the shadertoy.com soon if you're not familiar with it. If you want to learn more about Shadertoy, then there's the Shadertoy unofficial blog where you can get more information. And if you want to learn more about shader coding, there is the Book of Shaders. It's a very nice site that has some basic information that how you could start coding your fragment shaders. It starts from the very basics and then goes on to how to do, like for instance, random functions, how to generate noise, and these kind of basic elements that you will need when you are doing some more complex effects. So Book of Shaders is a really good website if you want to get more familiarized in shader coding. Then, of course, since we are talking about coding, I highly recommend you to check the OpenGL ES 3.0 reference page, because there you will have all the methods and functions needed to code shaders, and with some basic examples as well. If you want to know more about mathematics and graphics and code and how to do interesting visuals with math, then I highly recommend you to check articles by IQ of RGBA. Inigo Cuiles is the creator of shadertoy.com, and he has been working in Pixar and many kind of, let's say, prestigious American companies, and he has created a lot of very interesting fractal-based effects, and he has some very in-depth articles where he's explaining how the math works, and he's also showing very good examples that how you can generate some 3D in shaders. And then, of course, fast effect competition rules. But yeah, so all these materials are available either in the Telegram channel or then in shadertoy.com/user/waffles, so you can go and check it there. But yeah, so a bit about the fast effect compo. So as Rimina already announced about almost an hour ago, the theme of fast effect compo will be and is chaos theory. So we are expecting that when you are creating an fast effect entry, that you would do some sort of a graphics that are according to the theme. It's up to you that how you interpret that what chaos theory means. We gave one example of this very famous 64K intro called Chaos Theory in the beginning, but you can you can think for yourselves that what does the chaos theory bring into your mind when you start coding. And deadline is in Saturday, noon, 12 o'clock. So you have today, tomorrow, and Saturday morning time to code your effect. The full fast effect competition rules are available in the assembly website, but I'd like to point out a couple of things. So important thing is that the fast effect these competition entries are quite short. So the maximum playing time of the effect is 1 minute. And naturally, if your effect isn't that interesting for 1 minute, then organizers might cut it off before 1 minute has gone. But anyway, so you have a maximum playing time is 1 minute for your effects. And those effects will be displayed directly in shadertoy.com. So you will need to have a shadertoy.com account where you will do your code, and then you will put your shader in an unlisted mode. This means that the shader is not publicly available, but when you give the URL to your effect and to the competition organizers, then we can play that Shadertoy entry during the compo. So please keep your effects unlisted so that they are not visible to everybody in the shadertoy.com site. You can put them public after the compo has gone, but so keep them unlisted at least until Sunday to be safe. And then a bit about the regulations and laws in Finland. So if you are already familiar in shadertoy.com, I will have to mention that unfortunately, due to copyright laws in Finland, you are not allowed to use the textures, images, videos in the site. So this will be very purely an effect compo. So for instance, there are some video materials that the site provides you, but since the site doesn't provide the proper licenses to use it, so you cannot use it. So you need to do all your graphics and everything in the code. If you happen to be good at doing music, then there is actually a SoundCloud integration, and you can also generate audio if you want to. But remember that the copyright laws are also applicable in that case. So you need to have permissions for everything, and it must not be any sort of teosto or that kind of music. So how can you do the competition entry, and how can you submit it? 7 o'clock, Speakki will be talking in the stage about how to use the party management system in Assembly Winter. It's called Woohoo, and Assembly hasn't used this party management system before, so Speakki will give you a short introduction. But it's still quite easy to use, so you probably can also figure it out yourself. But anyway, so the party management system presentation will be done by Speakki on 7 o'clock. And of course, when you need to code the entry, you need to have some sort of a computer to do the actual entry. And the good thing in shader coding and shadertoy.com is that it supports a large variety of different kind of hardware. So basically, let's say that if you would be really adventurous, you could even use your mobile phone very likely to do the entry, but of course, since the keyboard capabilities are probably close to zero, I wouldn't recommend that. But if you're very adventurous, go ahead. So almost any kind of computer can run shaders nowadays. And as stated earlier, you need a shadertoy.com account. And to show you a bit about the Shadertoy, so this is the Shadertoy landing page. If you're not familiar with this system, it's basically a huge sandbox where everybody can do shader coding and can release them publicly, and then you can go and check that what kind of how the code has been written, and then you can even toy around with it. Like for instance, here's a ray fractal that doesn't seem to work in my computer, but that's live. So of course sometimes there might be situations that the effects won't work in the computer, but most likely they work. So when you have signed in to shadertoy.com, you can start creating new shaders by going to this new. And basically, this is the starting point of your shader coding journey in Shadertoy. So this is the default shader that is available, and it's basically just a rotating color palette in the screen. And then you can do changes however you want to. So just as an example, if we would remove everything from the screen, it would go black. And then if we would, let's say, if we would want to have just the screen showing a red screen, we could output the information to frag color, and it should put the screen red. And the good thing in Shadertoy is that you can immediately iterate and test it how much you like to. In Windows PCs, basically recompiling the code is as simple as pressing Alt and Enter, and it will change automatically. If you happen to have some sort of error in the code, then there is also some information that what went wrong, and you can try to debug your code based on this. Like for instance, it doesn't doesn't recognize an identifier of random text I just wrote here. But so this Shadertoy editor is quite good in showing you the errors that are occurring in the code. And if you want to, you can also write multiple shaders. You can use so-called frame buffer objects. I will talk a bit about them later on, but basically you can create sound with the system, or you can do multiple kind of frame buffers where you can move the output of a different buffer and utilize it as an input for your effect, for instance. So Shadertoy is quite good in doing these quick kind of iterations when you need to. But so all in all, it's really simple, and I just recommend you to just go and try and testing it how you see the best. Shadertoy is having some shader inputs available that are basically helping you in your coding. When we are talking about doing fast effects or demos themselves, I would say that you would mainly need to only use the variable iTime, which is basically just a variable that tells gives to your shader that how much time has passed. And this iTime you can then use to animate your effects. and because when you're going to show your fast effect compo entry, if you are not having anything animated, it might look a bit dull, to be honest. So I recommend you to do some animations with your effects. Unless if you're really good at doing still graphics, then you can do whatever you want to. Also, there are some other inputs, like you can have a keyboard input, you can have mouse input, etc. with Shadertoy. But when we are running these compos, we are not going to use or let you use the input devices. So if you're having some sort of mouse events, those won't be shown during the compo. But these mouse events and keyboard events might be very good if you need to debug your shader code. So you can use it for debugging purposes before you release the production. Yeah, so then let's continue. So I'm now going to show two different examples of shaders if you're not that familiar in shaders. So there is this Oblivion Radar by Endel. Which is just a simple two-dimensional effect that looks like a radar screen. And the effect itself, you can see the code here. I'm not going to go through it. I haven't written this, but anyway, if you want to learn more about shaders and how other people have done shaders, you can always iterate these shaders however you want to and test yourself that what they actually do. So, for instance, if I would go and let's say delete these rows, and then just test that how it's affecting the shader. So I can notice that okay, now the radar screen dots are gone, and then when I undo my changes, they are now back. So this is a quite a simple way, especially if you are not that familiar with shaders. Just go and dabble a bit with the shaders that other persons have written and check that how they work, and then maybe you can get inspired from it. But remember that copyright laws still do affect here, so please do not steal code or blatantly copy the code. But of course, if there is some proper licensing agreements available in the shaders, then you might be able to use the code. But anyway, it's a really good idea to go and check what kind of shaders other people have written to learn more about those. Then next example is from IQ, the guy who has done a lot of articles that related to math and graphics programming. This is a bit of a more comprehensive example, and this also illustrates that you can do quite a lot with Shadertoy. So basically, here's a render of a surfer boy, and also you can see that even the waves are animated here. Unfortunately, my computer's processing powers are running out, so the animation is not smooth. But luckily, this is not the compo machine, so don't worry. But basically, this example shows you that you can do a lot with the Shadertoy, and you can do really amazing graphics if you have the time Of course, since this is the fast effect compo and we just announced the theme, so I wouldn't expect that anybody would come up with something like this, because this takes probably a lot more time to do it. But anyway, this might give you some inspiration how to do 3D, for instance. So then a bit more about the Shadertoy and WebGL. So the shadertoy.com website is for you to code some fragment shaders. When we are talking about 3D programming, you in OpenGL, WebGL, there is actually multiple different kind of shaders that you could program. But in shadertoy.com we are only doing fragment shaders. And these fragment shaders are basically those shaders that create those pixels in the screen and create everything fancy that you see in the screen. There are also a lot of other kind of shaders available, like vertex shaders and geometry shaders, but you cannot utilize those in shadertoy.com. But if you are more interested in learning about GLSL coding in the future, then I recommend you to also check other kind of shaders. And all these shaders are for different kind of purposes. So for instance, the vertex shaders are for moving 3D vertices, and then fragment shaders are for putting pixels in the screen. The Shadertoy site, as mentioned, it's supporting WebGL 1 and WebGL 2 at the same time. So the site is WebGL version agnostic. So you don't have to know that what is the WebGL version that you are using, because it won't come up really. And the site is doing everything underneath the hood, because there are differences between these programming languages versions, but you are only coding in the portions where you cannot see the differences. And if you would want to know what is the WebGL version just for fun, most likely if you're using an Apple device, you will have a WebGL 1 in use, and if you're having a PC, you will use WebGL 2. But that's not really the point in Shadertoy, because you don't need to know the thing. And quickly something about the OpenGL shading language. So if you have ever programmed with C programming language, then you will already know that how to program shaders, because the look and feel of OpenGL shading language is pretty much same as C programming language. You don't have to know C, because the OpenGL shading language doesn't have that many functionalities. It basically have those, it has functions, it has variables, it has loops, it has conditions, it has basically all kinds of features that you would expect from a normal programming language. If you happen to have a background in coding, let's say JavaScript or some other not strongly typed language, then you might be having a bit rougher start, because all the variables in GLSL, OpenGL shading language, are strongly typed, meaning that you need to define the variables that you use. So, for instance, integer 1 is not the same thing as decimal number 1.0. Those are different types. But luckily there are not that many types, and you will quite quickly grasp this anyway if you're not familiar with strongly typed languages, so don't worry about that. the shading language has a lot of methods that help you to do graphics programming. So it has all kinds of trigonometry, vector, matrix calculation, helper methods. So most likely, if you are thinking that you need some sort of some mathematics method, please check first from the reference pages whether that method already exists or not, because it might very well exist and you don't have to write it on your own. But of course, sometimes if you have more esoteric methods or functions that you need, then you might need to write it yourself. Big difference in GPU and central processing unit versus graphics processing unit is that when you're doing when code is being executed in your graphics processing unit, it is basically the calculations are massively parallel, and this means that there will be multiple pixels are calculated at once when the screens are drawn. When compared to like for traditional central processing units, you might actually have more, let's say, iterative approach here that you don't you will need to set up the parallelization yourself. But the GPU is doing all the work in here, and it basically enables you to have a very efficient and quick calculations of your graphics and all the pixels in the screens. The caveat in GPU calculation is that since it's calculating all the pixels at one parallelly, it means also that you don't know during the calculation time, let's say that if you would want to take a value from some pixel near your pixel that you are drawing, you don't know the value because it's calculated at the same time. But so basically you cannot use the values of other pixels to do your effects. But there is also a workaround here called frame buffer objects. So basically in Shadertoy you can have multiple working stages where you can create some part of the effect and then use the working state output to as an input for next stage. So you can utilize these buffers, for instance, if you would want to do a glow effect or pixelize your screen or whatever you want to do. So basically you can use that if you need to know your pixel values later on. And that's about a quick introduction to Shadertoys and the OpenGL or WebGL, and I will now show a couple of examples that I have done to illustrate more about the shader code. So as a first example, just so that you would know that the Shadertoy is doing actually quite a lot under the hood. So basically here is the default Shadertoy example or the starting point. But if you actually want to know that what kind of code is being injected to your shader, I scraped the Shadertoy code base and added the code here. So if you are more familiar with the OpenGL shading language, then you can grasp that what kind of stuff there is happening also. So Shadertoy, since vertex shader, we are not doing vertex shader programming, but vertex shader is a thing that is mandatory in graphics processing. And so Shadertoy.com is actually having a default vertex shader, and which you cannot edit, because these are basically just a two-dimensional screen and you don't need to do any vertex shader editing. But if you're interested, here's the vertex shader code. that is used here. And then a bit more interesting part is the fragment shader, so the actual pixel graphics here. And this is an example of WebGL 2.0. If your graphics card supports only WebGL 1.0, the Shadertoy generates different looking code. But I'm only illustrating the WebGL 2.0 version here. And you can see that basically it's forcing you to have OpenGL ES 3.0. So it's basically the newer version of the OpenGL ES language that you're writing here. Then it defines different kind of precisions for your types. So for instance, it's defining that floating points and integers are high precision types by default. Then there are the uniforms, which Shadertoy.com is basically sending you information that you can utilize when you are doing your effect. And as mentioned earlier, you can see the shader inputs on top of your screen and then the comments that what they actually mean. But for the sake of fast effect compo, you mainly need to know the eye time here and eye resolution, most likely. And other uniform values are not that important. But of course the eye channel values are important, because these eye channels are the ones where I mentioned about this frame buffer object that you can do a working stage that you can utilize later on your effects processing. So these eye channels are basically the means that provide you the frame buffers that you can then read. The main image function is the function that where you are placing your shader code, and it's called then in the main function. And basically it doesn't do much. You can see that if you do nothing in the main image, the default color will be black, and also you cannot change the alpha color in your end output, because that will be then changed back by the main function. But yeah, this is just if you are more interested about the GL shading language, so you can go and check this out. But yeah, this is just the basic effect, so let's now go and check a bit about other effects that we have. So then some simple shapes. So here is an example how you can do two-dimensional shapes in Shadertoy. If you want to know more about how to do some more complex 2D shapes, again, IQ's articles and tutorials are most excellent, so I recommend you to check those out. But let's see what is happening here. So I will first go to the main function. So in the top of the main function, we are basically just setting up the coordinates, and we are forcing the aspect ratio of the coordinates to be according to the screen dimensions, because normally the coordinates are from 0 to 1 in x-axis and y-axis, and if you don't correct your aspect ratio, it means that it will then stretch and look weird if you don't do any changes like this. But then if you do the aspect ratio correction it will look more normal. And it doesn't matter even if you change the resolution or change the aspect ratio of your screen. Then the shape drawing. So the shapes, I have done some example shapes here, and if you want to utilize this code, go ahead. These are released under public domain, so you can do whatever you want with it. So first of all, we have the triangle function. So basically, what is drawing this triangle over here? And here's the math for it. I'm not going to go much deep here, but just to illustrate the point that since GPUs are doing massive parallel programming or processing of the screen, so you cannot draw your graphics in let's say, at least how I would assume that you would normally think. So for instance, usually when you would draw a rectangle, I would guess that you would probably have like 2 for loops, one going through the y-axis and one going through the x-axis, and then plot pixels. But as mentioned, these shaders, you are only plotting a single pixel at the time, and you don't know actually what pixel you are plotting. So in a GPU way of working, you should actually just find the boundaries of the shapes and then fill the colors that are over or inside the boundaries. And that's how you are doing the GPU programming. So basically doing a rectangle in a GPU way of working would be that you understand that where are the boundaries of the box and then know that how to fill it inside. But yeah, so this is the way of working, and this 2D drawing, if you have seen ray marching graphics or whatever, this is quite similar way. So basically we are calculating distances and then we are filling different values here. Then there is the circle, and the circle is empty inside, which is basically achieved in a way that you draw two, or you define two circles, and then you just define that the other circle is actually then doing the circle hollow. So you define bigger circle and a smaller circle, and that's how you make it happen here. And I'm using here minimum and maximum numbers basically to join these simple shapes together. So since the distance inside the shape is actually a negative value, so when I'm having a minimum value here, it means that I'm combining the shapes together. And if I would want to remove the circles here, again it would be done like this. And if I would like to just have the single circle here, I would just remove the maximum from here, and then now it's a normal circle. Then the maybe a bit more complex shape here is the cross shape, and just to illustrate that how the cross is drawn, it's I did it a bit more simplistic way. So basically this cross is just two rectangles that are rotated. If you actually need to have more performance, to draw these shapes, this is actually not a good way to do it, because this is terrible from performance-wise, but I felt that this is a bit more simpler way to show how you could join different shapes to create more complex forms. But again, IQ's tutorials are having some examples how you can do very complex shapes or 2D shapes that are actually also optimized. So you can see, you can go check the IQ site and you can see the better way how to do this cross. But it's just to illustrate that you can join different shapes and create more complex shapes by that way. The background color is again the default color that is from the shader template in the Shadertoy, and it's drawn here. How the shapes are actually drawn, it's done in this code part. And also, you probably cannot see it from here, but I'm showing here two examples of the shapes. So the upper part of the screen is showing shapes that are anti-aliased, and then the bottom part is basically aliased shapes. So if you so basically, when you're doing shader coding, you need to do your anti-aliasing yourself, and if you don't do, then you will have a bit more blockier and visible pixels in the screen if you don't implement anti-aliasing. But here is an example. How you usually are doing the anti-aliasing in shaders is by using so-called smooth step function, which is available in GLSL. So I recommend you to check it out if you're not familiar with it. And then here is just an example of the aliased way of doing it. And then next up, I will go a bit further and show you how to use the frame buffer object and the Roto-Zoomer. And these codes are available and public, so you can go ahead and look the code later on. But so here's an example of a Roto-Zoomer. This is a quite classical effect, and you can see how slow-mo computer is. And this is a classical demo scene effect where you are basically just having a texture that you are rotating and zooming in and out in the screen. And basically how how I have done this is that I have a frame buffer object called buffer A, which is basically doing this shape, smiley face with a bad looking black and white pattern. And if you look closely, this pattern is seamless, because when you're doing the Roto-Zoomer effect, and if the pattern would not be seamless, it would look a bit bad. So if you are wanting to do some sort of Roto-Zoomers, I would recommend you to do seamless kind of graphics, so that it doesn't look that there are bad looking seams all over. And then this again, this picture has been done the similar way as I did the normal shapes here. So basically, I'm drawing the yellow face first in the background here. Okay, in the absolute background there is this black boxes in a white background kind of pattern, which is done using modulo function, so that it has the repeated look and feel. And basically, by changing the modulo, you can then change how the patterns are repeating. Then the face the background of the face is the yellow circle. Eyes are just two smaller circles, and then the mouth is two circles and one rectangle. So to show you how it looks without the rectangle, which creates the mouth, you can now again see that this is just two circles, and then by adding the rectangle here, we can make it look like a smiling. And this shader has been done to the buffer A part, and in buffer A, the output is going to a buffer, and then the actual data that is shown in the screen is done in the image section. And in the image section, I need to define that I'm using the buffer A. So I need to basically click the channel here and then define that what I'm doing, what kind of input I'm using in the channel. And here I can select the buffer A, and then it will have the buffer A. There are also some settings that you can use. So the default settings are linear and clamp for the texture. So if we would put the zoomer back in, it would look a bit different with the default settings. So since it's a clamped texture, there is no repeating like in the beginning. But so it has to do with the wrapping mode of the texture. So you need to put the repeat mode on in order to have the Roto-Zoomer look and feel. But the filters and wrappings are giving you different kind of possibilities to change this buffers if you want to. But yeah, and this is if I'm deleting the buffer, then it looks like this. So just take a look at the Roto-Zoomer effect if you want to learn more. Then the last effect I'm going to show is a bit more advanced, but I have actually taken out a lot of stuff so that you can then try to learn more. This is a ray marching metaballs effect, so more or less a 3D effect in the shader screen, and the 3D is done via a technique called ray marching. And ray marching is basically that you are sending rays from your point of view, and then you are defining object boundaries, and when the ray touches the object boundary, there will be then the pixels formed here, like these metaballs. And this is a really simple way to do ray marching. You can do a lot more complex ray marching. You can add reflections, shadows, whatever you want to. But this is just like a very basic way how you could do it, for instance. And the animation part here is basically that I have defined 5 spheres here, and they are moving by using cosine and sine functions together with the time variable, which will add them moving here. And then there is a loop that is going through all the spheres and adding them here. And basically that's how you are able to do some ray marching. And if you are going to go and do some really awesome and good looking ray marching, I would say that this is one way to do really impressive effects. But you need to then learn how to do reflections, use light and everything. but this is the most simplest form that there can be. And you can check it out and tweak with it and maybe do some more to if you want to. But yeah, this effect was used in the assembly summer 2009 invitation demo, and this code is basically almost one-to-one to the invitation effect code. And that is basically all the effect examples that I have shown here. I will just add the bootstrap as public as well. And it's up to you what kind of effects you want to do in the effect competition. And these effects are something that you could do really quickly, and since you have tomorrow one complete day and then you have Saturday morning, so you have actually quite a lot of time if you want to do some more robust kind of effects. But if you want to have some starting point, then take a look at these effects and maybe try to do some animation, try to change how they are working, and then maybe try to find what is your interpretation in the theme chaos theory. And by that way you can do some very awesome shaders. That's basically all from the presentation side here. I will be in the scene lounge for next couple of hours, and you can come and ask some questions if you want to know more about shader coding, or if you want some design tips or whatever, or if you want to know more about the compo rules. And so please ask what you want, and hopefully you will have some good time in coding the effects, and I'm hoping that as many of you can participate the compo. Thank you.